So in grade 9, if you recall, you learned about linear relations. That's what you learned in grade 9. Even in grade 10 applied, you learned about it. And the equation was in the form of y equals mx plus b. Y was the dependent variable, x was the independent variable, m was the slope, and b was the y-intercept. In this chapter, you're going to be learning about a new relation. It's called quadratic relation, which I think in grade 10 you learned about it a little bit. And the equation is in the form of y equals ax squared plus bx plus c, and a cannot equal to 0. And we just start with a basic example, something from grade 9, grade 10, linear relations. We have y equals 2x minus 1. We have a table of values. We want to evaluate the value of y. So what we're going to do, we're going to substitute these x values that we selected for x, and we're going to calculate y, either using mental math or using your calculator. So if x is negative 3, 2 times negative 3 is negative 6, minus 1, it's going to be negative 7. And negative 2, if I plug in negative 2 for x, 2 times negative 2 is negative 4, minus 1, that's a negative 5. Plug in negative 1, you end up with negative 3. If x is 0, y is negative 1. If x is 1, y would be 2 minus 1, which is 1. If x is 2, 2 times 2, 4, minus 1, that's a 3. And if x is 3, 3 times 2, 6 minus 1, it's going to be 5. So we selected x values. These are the values that I selected already. You can pick any number you want. And the values of y we did calculate based on the equation of the linear relation. Now in grade 9, there was a third column we added to this table of values, if you recall. It was called first finite differences. It was the difference column. So we are finding the differences between the y values, always the lower number minus upper number. So negative 5 minus 7, basically. That will be the difference in the y values. We call this first finite differences. Negative 5 minus 7 is going to be a 2. And then again, the difference between the next two y values, negative 3 and negative 5, it's going to be negative 3 minus 5, which is a 2. And then similarly, the same one, negative 1 minus 3, it's going to be a 2. Next one would be 1 minus 1, which is a 2. 3 minus 1 is a 2. 5 minus 3 is a 2. And you notice that all these numbers, all these differences actually from top to bottom are actually the same, number of 2. So it is the same constant, basically. We have all these finite differences top to bottom, and they're all equal to 2. If you have a relation where the first finite differences are all the same number, we call this relation a linear relation, as you recall from grade 9, grade 10 math courses you have learned in the past. Now, we want to construct a similar table of values for the quadratic relation. Okay, so we have a very simple quadratic relation, y equals x squared. The exponent of x is 2. If you raise negative 3 to the power of 2, you will end up with positive 9, because negative 3 times negative 3 is equal to, actually, negative 3 squared is equal to 9. Negative 2 squared would be 4. Negative 1 squared would be 1. 0 squared, 0, 1, 4, 9. So this is how you calculate the values of y. And then if we construct a similar column, first finite differences, so FD I call it sometimes, first finite differences, that will be bottom number minus top number. So it's going to be actually 4 minus 9, which is negative 5. 1 minus 4 is the next one, which is negative 3. 0 minus 1, that's negative 1. 1 minus 0 is 1. Lower number minus upper number, 4 minus 1, that's a 3. 9 minus 4 is a 5. And this time you notice that not all of these numbers in the first finite difference column are the same number. Before, in linear relations, they were all top to bottom same constant. It was 2, 2, 2, all the way. But this one, this quadratic relation, we see that these differences are not the same. So we're not going to lose hope, and we're going to continue with another column. So this time we're going to find the second finite differences. I put 2FD, second finite differences. So we're going to find the difference between the values in the third column. Again, bottom minus top, -3 minus -5. That is going to be a 2. -1 minus -3 is a 2. 1 minus -1 is a 2. Even 3 minus 1 is a 2. And you see that this time we ended up with the same constant top to bottom. In this exercise, it happens to be 2, but in other exercises, it could be like 4, 4, 4, 5, 5, 5, top to bottom. But what is important is that all these numbers were all the same constant. Same constant from top to bottom. And this is the second finite differences that are the same, unlike the linear relations where the first finite differences were all the same. That's the major difference. So whenever the first finite differences are all the same number, top to bottom, we call the relation a linear relation. But whenever the second, but not the first, second finite differences is all the same number, top to bottom, then in that case we call it a quadratic relation. Now, very quickly, I'll try to plot these points and draw the graphs of these two relations. So -3, -7, -2, -5, I'm going to be quickly plotting these points. You have to do this on a graph paper. -3, -7, so I think it will be a point here. That's -7, and -3 is here. So that will be a point here. I plot it, -2, -5. That's another point. -1, -3. 0, -1. 0, -1 is here. Now 1 and 1 is right here, 2 and 3, and then 3 and 5. So these are the points I plotted from the table of values. I have 2, 4, 6, 7 points. 1, 2, 3, 4, 5, 6, 7 points I have here. So now it's time to draw the graph of this linear relation. Using a ruler, of course, at home with the use of a paper and pencil and ruler, you can do a much better job than I'm doing here. So we're going to extend the graph from both ends, and we're going to draw the arrows to show that the line is unlimited from both ends. We quickly label the graph before we forget. Y equals 2x minus 1 was the equation of the line. You notice that -1 is actually the y-intercept, and of course the slope of this line is 2, as you recall from 2 years ago. Now, the other graph, quadratic relation, if I just plot the points using the constructed table of values, I have -3 and 9. So -3 is here, 9 is up there, -2 and 4 is here, -1 and 1, 0, 0, and 1 and 1, 2 and 4 is here, and 3 and 9 back again is up there. So if I draw this graph, it's going to look like something like this. I end up with a symmetrical graph, symmetrical with respect to the y-axis. So this is how the graph will look like. This is a U-shaped symmetrical graph, which has a special name. We call it, of course, a parabola. A parabola is the name of a quadratic relation. It's a U-shaped symmetrical graph, as you see. I'm going to quickly label the graph with its equation, y equals x squared. And you may notice that this curve, it's not a straight line anymore, has a lowest point. This lowest point here, the origin right here, has a name. We call this point the vertex of the parabola. You may recall from grade 10 math course you took last year. Vertex is the lowest ever point on the graph of a parabola. Okay. Sometimes, of course, parabolas are opening downwards like this. In that case, the vertex would be the highest point on the curve. But sometimes it is opening upwards and it's showing the lowest point. Like the lowest point is called the vertex. And as I said earlier, the y-axis is like cutting this graph in half. In other words, we can say that there is a line of symmetry here, which we call it axis of symmetry. I just draw it here. It's called axis of symmetry. Axis of symmetry. The equation is, of course, x equals 0. It's the equation of the y-axis, basically. And this axis of symmetry, what it does, it passes through the vertex and it cuts the parabola in half. The lowest point, the vertex, is also known as the minimum point. If the parabola opens downwards, then it will be called a maximum point. So this is like a maximum point. The vertex is a maximum, but here we say that the vertex is a minimum point. Okay, this much for the first lecture is good enough. I want you to graph these two linear relations as homework for you, and graph these two quadratic relations using the same method that I just graphed these earlier. You construct table of values, plot the points, be meticulous in your graphing, use a graph paper, use pencil, and draw these 4 graphs, 2 linear, 2 quadratic, on a separate grid. And then we're going to continue in the next lecture talking more about these quadratic relations. Okay? Thank you very much for your attention, and let's work together hard so that we can finish up this year's this school year successfully together. Thank you.